Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
Yeah, so today's topic is class intervals. We're still on the statistics, last section of the syllabus. We're probably going to be on the statistics for a couple of weeks, for a couple of sessions. So I'm going to be talking frequency. You're going to be hearing me saying frequency data a lot, right? That's what statistics fundamentally is. Now, class intervals, like I've been mentioning when we are looking at frequency tables, it's basically you grouping data, right? You're grouping data according to a specific class. Now, so frequency table with group data, from what we understand, is basically when we group the data set. For instance, yeah, look at, we have some examples, right? Now, this is purely stuff that I've done with you before, so all of this should just be recalled. This so far, right? Frequency tables, right? Now, frequency table with group data is class intervals. Once you have frequency table with group data, you're looking at class intervals. Those groups are called class intervals. I mentioned last time, why would you go ahead and group the data? Is because you're considering a large range of values. This is the key term. Why we go ahead and even consider grouping data instead of just listing them out as on group data is because there might be a large range of data to work with, a large range of values, specifically values, right? Because if our observations are not values, then we can't group, right? We can still group, but it won't be class intervals, right? It won't be the mathematical class intervals that we're talking about. So class intervals, group data, usually done when we're looking at a large range of values. It's also done when we're looking at continuous data sets, continuous data. Now, there are two types of data that you need to be familiar with. It's discrete and continuous, right? And this is what I want you to take away from this. This is what's new, right? Everything else that I've mentioned to you before, but this is what's new. There's two types of data. Now, what I told you last class was grouped and ungrouped, right? Those are the basic terminologies I use for these two. Ungrouped, well, I don't want to say this is ungrouped, but you use discrete data, you find them being ungrouped, and for continuous data, they're usually grouped. Right? Now let me explain what these two types of data, how to distinguish between these two types. So discrete data refers to definite known values that can be identified and represented directly. So we're looking at mostly natural numbers, right? You're looking at mostly natural numbers, or in some cases, you might have some rational numbers. But these are definite values that don't fluctuate based on the, okay, shoe sizes is a bad example. Like shoe size is a bad example. But the simplest way can tell you to think of it, think of natural numbers is the most cases how discrete data, right? You'll see discrete data as natural numbers. Now you might see a 0.5 here and there, but most discrete data's values are natural numbers, right? So that's the point to take away with discrete data. It refers to a definite known value that can be identified and represented directly, right? Now with continuous data, it doesn't have necessarily an exact value. What happens is that we tend to round it off, right? We tend to round off continuous data values. For example, so with continuous data, and it's more common to see Well, it depends on the what kind of information you're looking at. But with continuous data, the value is not always the exact, and because of that, we say the data is continuous or taken along a continuum. It can range from, it can have a certain range of values, right? Your weight, for instance, is a perfect example because no perfect balance. At least I can pick up 5 random balances from the different, of course, different brands from the mall, and they won't all give me the same weight, right? They might differ based on by a decimal point and that kind of thing. With discrete data, that never happens. It's one single value all the time that you're going to be working with. Like number of persons in your class. If you have 5 persons in your class, there is no if, what, or maybe about that, right? With continuous data, there is a if, what, or maybe, and that's because the data is within some range of values. That's enough. I digress. That's as much as I can explain concerning the difference between discrete data and continuous data. Again, discrete data, think of natural numbers, sometimes rational, and continuous data, most of them are rational numbers. Right? Now, like I've explained before, we've looked at frequency tables, and we know the 2 types of frequency tables that we can see is one with ungrouped data. That's when our observations are not grouped according to the classes, are not grouped according to a set class. Now with ungrouped data, with group data, we group our observation in classes. Now this data set exercise was given to 13 students at these lessons, and their performance was plotted on the 2 frequency tables, right? Question number, and now I recognize that there is some discrepancy with the data set, but ignore it if you can recognize it. But we have our observation column 1 to 16, and we have an observation column in our group data set arranged in class intervals, right? And we know what frequency is. This is straightforward. What I really want to get over here is that when the new word for this group data is, these are what we're calling class intervals, right? These 1 to 4, 5 to 8, 9 to 12, and 13 to 16 is what we're calling class intervals. This is what we're going to learn about today. Right? So what about class intervals are we going to learn today? These 5 things. Now, the thing about these 5 things, they're more or less, once you know them, for those of you that did not raise your hand when I asked if you've done class intervals before, once you know them, you tend not to forget them, right? What a class limit is, what a class boundary is, what a class midpoint is, class size, and class rank. Now, it's important for you to be able to identify all 5 of these things because with maths, we're going to be building off of this information. So you can't forget how to identify class limit, class boundary, class midpoint, size, and rank. Because when we go to calculate stuff like mean, mode, and medium from our frequency table, we're going to be using some of this because we have our data set arranged in groups. We need to use the components of the group, right? Our class interval. So we're going to start off with what a class limit and a class boundary are, right? A class limit, I've introduced this to you before. The class limit are those end values of the class intervals, right? So that's what you're going to take away. The class limit are the end values of the class intervals. And you see an example here just now. So each class interval has each class interval has 2 class limits, a lower limit that's to the left and an upper limit that's to the right. So the one that is the lower limit, of course, is the lower value. The one of lower value is called the lower limit. The one of higher value is called the upper limit, right? Low and upper, you shouldn't be able to mix those 2 up. The one on the left, the lower number, usually on the left, is the lower limit, upper limit And this is a basic example from what we've been using before, 35 to 39. The lower limit is 35, the upper limit is 39. Straightforward, can't get easier than this. Class boundaries, the class boundaries is considered to be the average of the class limits. Just a bit of a, I'll explain what that means just now, but the easiest way to get it, this is what the textbook says. The two class boundaries, there are two class boundaries. Like with class limits, there are two class boundaries, an upper class boundary and a lower class boundary. And you can already guess the lower class boundary is the one of lower value, and the upper class boundary is the one of higher value. Now with the class boundary, it's important for you not to mix up class limits and class boundaries, right? Make that distinction right now between limit and boundary, because a lot of students make that mistake. When you ask them for class boundary, they give you the class limit, because it's easy to identify the class limit, right? 35 and 39, these are class limits. But the class boundary, at least for this class interval, you see it, but toward the same example as before, 35 and 39, the class boundary here is 34.5 and 39.5. What do you notice with the relationship between our class limit, let's say our lower limit and our lower boundary, and our upper limit and our upper boundary? What is it that you notice? Let's see if anybody is paying attention. But you notice with the values, same here. You can look at this one. This is 40, this is 39.5, this is 44, this is 49.5. You might see it better if you look at the upper limits and the upper boundaries, each one of these. Right? The upper limit is 39. The upper limit is 39, and the upper boundary is 39.5. The upper limit is 44. The upper boundary is 44.5. The upper limit is 49. The upper boundary is 49.5. I can't spell it out more than that for you. What do you notice, at least from what I just said, about the relationship between the upper boundary and the upper limit?
The upper boundary is the upper limit plus 0.5.
Good. That's as easy as it gets. You just need to remember that, and you always get the upper boundary. So the upper boundary is always equal to 0.5 plus 0.5 of the upper limit. And applying that same logic, what do you notice between our lower limit and our lower boundary? It's 35.
Yes, I'm saying it's 0.5 less.
0.5 less, right? So that's what I want you guys to take away from class boundaries. How do I get the class boundaries? Once you know the class limits, you automatically know the class boundary. But I still have to explain this little statement here when it says that class boundary is considered to be an average of the class limits. Now, let me explain this. And that's why I have multiple class limits laid out. Class intervals, sorry. So in this card, I'll explain this. Now, you don't really need to remember this, the class boundary, but for the sake, for your sake, I'm going to explain what this is saying. That the class boundary is considered to be an average of the class limits. What does that mean? Okay, so if we're looking at the class limits, right? Let's say, for instance, yeah, let's say that, right? We have these two class limits, the upper limit for this class and the lower limit for this class. It's an average between two separate class limits, right? Not for the same class interval. Notice I didn't take 35 and 39. I'm taking class limits from two different class intervals, from two different groups, right? So the class, I'm taking the class limit, the upper limit for 35 to 39, and the lower limit for 40 to 44, right? Now, if I find the average between these two values, it's going to be 39.5. And how do we find the average? Average is sum divided by amount, sort of like probability. And the sum is 39 plus 40 divided by the amount of numbers. 39 and 40 are two numbers, And to 9 divided by 2, we should get 39.5, right? And that's why you say it's the average between the class limits. We're not looking at, right, so right, so let's take two class intervals, two consecutive class intervals, right? Four. Good. And I want to know the upper boundary here. I'm just showing you this. I don't know why you don't need to remember this, but I'm still going to show you it regardless. So the upper boundary here, do you want to know the upper boundary? You can just add 0.5. That's the easiest way of doing it. And that's the way I prefer for you to do it. But the other way of doing it is to actually find the average between your lower limit and the consecutive upper limit, right? And that here is 39 and 40. And that will give us, if we find the average between the two, I just showed you the working, it will give us 39.5, right? If you want to know the lower limit, well, the up, I said lower limit. If you want to know the upper boundary for this class interval, the second one, 40 to 44, yes, you'd go ahead and just add 0.5 to 44 and it will give you the answer. But the another way of doing it is to take the lower limit, the upper limit, sorry. I was saying upper limit when I should be saying, I was saying lower limit when I should be saying upper limit. Apologies for that confusion. All right, so upper limit 44, and we want to get the upper boundary for the same class limit, for the same class interval. We just take again the upper limit for the class interval and the lower limit for the consecutive class interval. So consecutive class interval would be 45 to 49. So we just take these two, find the average value between those two, 44 plus 45 divided by 2, and that should give us 44.5. Do this enough times, you will recognize you just need to add 0.5. Which mathematicians sit down and actually they felt that finding the average between these two made any was worth it? I don't know, but that is what this statement is trying to get at, right? The class boundary is considered the average between the limits, right? Again, those limits are from different class intervals. Any questions or queries so far? Are we okay? We understand what class limits are, how they differ from class boundaries, and we also understand how to calculate our class boundaries. Now, this is what I said, right? But you guys identified this, not me. The lower class boundary is equal to the lower limit subtracted by 0.5, and the upper class boundary is equal to upper limit plus 0.5. The next two we're going to look at, the next two components of our class intervals, the writing is a bit smaller here, is the class midpoint and the class size, right? When you talk about the class midpoint, we're talking about that middle value in our class interval. And the class size refers to more or less the number of values within our class. More, I want to say, okay, I'm not going to say that. All right, so the class midpoint of a class interval is defined as the average, you can't get away from this average, of the lower and upper boundaries of the class. So you can't get the class limit without knowing what your lower and upper boundaries are. And please use your lower and upper boundaries, not your lower and upper limit. You'll get different answers, right? So the class, so the class midpoint is also called class midmark or class value. Now, I've never actually seen it been called class midmark or class value. But please, by that I mean I've never seen it in a CSEC exam in a text being called this before, right? But these are some other names for it. It can be called class midmark or the class value, right? But what the class midpoint is, the average of the lower and upper boundaries. In other words, the class midpoint is equal to the lower boundary of the class plus the upper boundary divided by 2. That's how you find the averages. We were just doing that just now when we are looking at the average between the class limits, consecutive class limits, right? So just add your upper boundary plus the lower boundary and divide it by 2, you will get your class midpoint. Now, I want to ask, what do you notice about your class midpoint? For the class interval, this is just an example here for the class interval. We like this to use this one, 35 to 39. For the class interval, 35 to 39, the class midpoint is, again, class midpoint is equal to the upper boundary. How did I, the upper or lower boundary plus the upper or lower boundary, same thing. So the lower boundary is 35, 34.5. Again, I got that from subtracting 35.5 from 35. And I got 39.5 by adding 39.5 to 39, right? So that's how I got my upper boundaries, my upper boundary and my lower boundary. Add those two and divide it by 2, and I will get the class midpoint. So the class midpoint for this class is 37. Now, something you'll notice about the class midpoint, if I list the natural numbers between 35 to 39, right? Remember, this is our limits, our upper limit and our lower limit. The class boundary is actually in the middle, right? Yeah, you can see that. The class boundary, the class midpoint, sorry. The class midpoint is actually in the middle. And that's why it's called the class midpoint, because it's in the middle, right? 37. So if I list, and I list them as natural numbers, this is the easiest way you can see. So you can see that your class midpoint is actually in the middle. Again, we're looking at values from 35 to 39, right? The lower limit being 35, list your natural numbers up to 39, our upper limit, and you will see that your class midpoint is actually that middle value. Now, your class midpoint isn't actually always going to be a natural number. In other words, a whole number. You might get a 0.5 or something like that, depending on what is called your class size. It depends on your class size. If your class size is odd, you will get a wrong value, a whole number. If it's even, then of course you're gonna get a 0.5, right? If you're paying attention, you know why that will happen. Now, class size, right? So that's our class midpoint, is just the middle value. Again, use this to calculate it. Do not do this cheeky move that you see me that I just did by just listing it and then finding the middle value. Do conceptually, that is correct. Double check, is always good to double check with some calculations, right? With this calculation here, this formula. Good. So the class size is the width of the class. The class size is considered the width of the class, also known as the class size or class width. Is defined as the difference between the upper and lower boundaries. Just subtract the upper boundary from the lower boundary, right? So the class size is equal to upper boundary minus lower boundary, and that will give you the class size. So you notice for so far we're using our upper and lower boundaries to get our class midpoint and our class size, right? And the example here again, for the class interval 35 to 39. The class size goes as follows. Class size is equal to upper boundary 39.5. Again, just add 0.5 to get your upper boundary, and minus 34.5 again, subtract 0.5 from the lower limit. That's how we got 34.5, and you will get 5 as your class size. Now, conceptually, what that means is that if I wrote 35, 36, 37, 38, 39, right? Again, we're going from 35 to 39, or up and lower limits. If we count how many numbers are here, how many natural numbers are here? 1, 2, 3, 4, 5, right? 5, right? That's our class size, right? So that's how you can understand this conceptually. And for our let me put this down as well. Like Rihanna has already told us, the class rank refers to the position of the class interval. but where and relative to what? In the frequency table and relative to the other class intervals. Right. So for the class rank, for the example below, we have our table from before, where 16 questions to 13 students, yada yada yada. The class rank of this class interval, 5 to 8, in the frequency table below is second, because it's the second class interval given in the table. So the class rank is a relative value, meaning that it depends on its position in the frequency table, right? And of course, most of your class intervals, the reason why you have class intervals is to represent, is to put it on a frequency table or put it on a graph, right? So first, second, third, fourth, those are the class ranks for these class intervals. What you'll notice is, if I was to go ahead and calculate the class size for this class interval, 1 to 4, right? Again, class size is, okay, I'm going to use the cheeky way of doing it. Class size is 1, 2, 3, 4. Class size is 4, right? Right? The class size is 4. Now, okay, I'm going to show you the of course, we know that it's the lower limit, upper limit such like the lower limit, not the other way around. The upper limit, which would be 4.5. Again, this is the other way of calculating class size. We just showed you it. The upper limit, which for 1 to 4 would be 4.5 minus the lower limit, which would give us 4. Same thing, right? Is one way of doing it. The second way of doing it. Now, you have a class size of 4 here. And when we go to this one, you can put your last button. You could bet. You put your head on a block that this class size will also be 4. This class size will also be 4. This class size will also be 4. And this class size will also be 4. The reason for that, if you don't see it, I'm going to do one more. 2, 3, 4. Size equal to 4, right? If you want to do it, the upper boundary, sorry, minus lower boundary. 12.5 minus, why keep writing the lower boundary first? Upper boundary 16.5. Lower boundary would be 12.5. That'll give us 4. Right, so the class size for each one of these class interval is 4. Now, when you're doing up, this is because I want you guys to notice, is that you stick with the same class size when you're using class intervals, right? You always stick to the same class size. You can't go 1 to 4 one time and then decide to increase your class size, right? Just because, right? So 1 to 4, I can't say 1 to 4. The next one has to be 5 to 8, has to be 5 to 8. It can't be 5 to 9 or 5 to 10, because if I go any farther than 5 to 8 or any less than 5 to 8, it won't be the same class size, right? So, and that's how I was able to predict the class, the class before, those two consecutive classes, the class before and the class after 35 to 39, because if the class interval is 4, then the class after has to be the same class size and the class before has to be the same class size. So for a grouped data set, so for a grouped frequency table, the class size of your class intervals remains the same. I'm going to say that again. For a group frequency table, the class size of your class intervals remains the same. And when you're constructing your data, and you have to come up with class, you have to come up with your class intervals, don't go and be using those ranges willy-nilly, right? It needs to be the same size throughout. 10, 20 random numbers is five numbers to each one of you. So this is the exercise. We're gonna grab 20 numbers, 20 random numbers between 1 and 15 from you guys in the class. Whole numbers, of course. I don't want anybody calling out decimals. And you guys are gonna construct a group frequency table using these class intervals. Calculate the relative frequency of this class. Calculate the following for the class intervals. Write the following components of the class intervals in your group. The lower boundary, upper boundaries, for each one of them, right? Lower boundaries, upper boundaries, class, midpoint, class size, yada, yada, yada. And then calculate the probability that a student chosen at random picked a number between 1 and 5. Now this one is a bit tricky. That's why I give you guys a hint, because we haven't done probability as yet. So this one might be a bit tricky for you guys, at least until we do probability. And so this one, let's say what you guys should try, right? To look at the frequency of the class 1 to 5 and the total frequency. That there's a big giveaway how to calculate how to get the probability, right? So we're gonna go on the class, get our random numbers, and then you guys are gonna proceed to do these things. Now, five. I need you guys to confirm this for me. It's correct. 7. Rocco says 7. One more person.
Sir, 7.
And then the last one, 5. We got 5. Take that the 7 to the yes. We got 5. No. Yes. No. Y'all checking back. We got 5. All right. So it's 11 to so 1. Okay. This is so you got your headings and you got these values correct. That would be 4, right? I would do 4 to 4. Now, part B asks us to calculate the relative frequency of class 1 to 5. And we know relative frequency. Relative frequency is equal to the frequency of the event, which is 1 to 5, divided by the total frequency, multiplied by 100%, because we want to express as percentage. So for the frequency of 1 to 5, that is 8, right? You just use your table. The frequency for 1 to 5 is 8, and the total frequency is how much?
20.
Sir, 20.
20, right? I remember we know that from this, right? It's 20 random numbers in an right? We know that from since the beginning. Or you could have, if you had time, you could have just added the total here. Multiply this by 100, right? Now we could do some reduction here. 0.82, 5, 20, 5. Around 5. Yeah, 40%. 5 here. This will go down to, okay, let me take my time. This you could get this down to 5. And get this down to 1 and 20. And I'll give you your 40%. Or you can find another way. 40%, right? So see now, asked us to get the lower boundaries for each of the class limits. So I'm just gonna write these out for you guys. I don't think these should be a problem. So for this one, the lower boundary would be 0.5. The upper boundary would be, this is part. Yeah. Part C, A, right? Upper boundary would be 5.5. I'm gonna write these out. So from 6 to 10. Now you'll notice for what you'll notice is that for each consecutive yeah, for each consecutive lower boundary. Yeah, for each consecutive class interval, the lower boundary for one class interval is the upper boundary of another. The upper boundary for one class interval is the lower boundary for the next. Right? Okay, raise your hand if you see what I'm talking about. All right. Yeah, I don't know why I'm stuck here. All right, so that's the boundaries. Next is class midpoint. Now for the midpoints, you should see a pattern here as well. I'm just gonna write the answer. Class midpoint here would be 3. Class midpoint for 6 to 10 would be 8. And the class midpoint for 11. Again, this is class midpoint. Yeah, Kazako.
Isn't the third class interval 11 to 15? So wouldn't the upper class boundary be 15.5?
Yep. I think it's done. What thank you. Good. No, paying attention. And here again, the class midpoint here would be 13. What do you notice for your class midpoints? We saw a pattern for the limits, for the boundaries. Did you guys see a pattern for the midpoints as well? Hoping that you guys saw it. Anyone saw the pattern for the midpoints? For each consecutive, so the class midpoint for the first, using the class rank, right? For the first class interval, it's 3. For the second class interval, the class midpoint is 8. For the third class interval, it's 13. If we had a fourth class interval, we could actually predict, because we know what the class size will be, we could actually predict the class midpoint just by knowing the midpoints of the others, because the pattern here is you're just adding 5 to the previous class midpoint. So for each consecutive midpoint, we're just adding 5. All right, so 5 plus 3 will give us 8. 8 plus 3 is 13, and 18. You guys see what I'm talking about? Or raise your hand if you okay. No one said they saw that, but raise your hand if you get what I'm saying, if you see what I'm saying with the class midpoint, a pattern. So I'm sure you guys are following. All right. All right, so that's the pattern with the class midpoint. You know the pattern of the upper and lower boundaries. Wait, this is big part. See. And the class size. You already know the class, the pattern with the class size, right? Once we find out one class size, we know all the others. And that's 4. Okay,
Sir, what?
Okay. I'll put 5. All right, so I was just trying to see if you guys paying attention. So 5, right? And once we know one class size, we know all the others, right? And so there's no pattern to see here. It's constant. Class size is constant. So that's brings us to the last question. Oh, I'm going over the time. My apologies. The last question, it's asking us to calculate the probability of a student picking a number here at random between 1 and 5. Now, probability, you will learn the probability of an event is equal to the number of times that event occurs divided by the total possible outcomes. Fancy jargon, all it means is it's the same as relative frequency. Right? Probability is the number of frequency divided by the total frequency. Knowing that the number of frequency for 1 to 5, basically the same thing, 8 divided by the total frequency, 10, right? Total frequency. Right, so it's 8 divided by 10, 20, sorry, I'm saying 10. And we know this fraction already, right? 4 into 8, 2, 5, 2/5. Should get 2/5, right? And those are the answers. Again, probability is the same. What you need to recognize the probability is actually the same thing as your relative frequency. So take that away. Probability and relative frequency is the same. And it's like relative frequency, which can be expressed as a fraction or a percentage. Probability can be expressed as a fraction or a percentage. Same rules, same rules.